and welcome back to Vector X Academy. This is Satyaj, and in today's class we will be learning a new chapter called probability. Now, many of the students faces difficulties solving questions from this chapter. Today I will show you some techniques which will make this chapter very easy. So, let us get right into it. Now, let us start with some basic definitions. The first one is sample space. Now, what is a sample space? A sample space is a set of all outcomes when we do an experiment. Suppose we did an experiment like tossing a coin. Now the outcomes we can get will be either the coin will fall on heads or it will fall on tails. So the sample space will be heads comma tails. Now instead of one coin we cast two coins. Then the sample space will be either both are heads or one head and one tail, and the second one is first one is tail and second one is head, or both are tails. Now the set of all outcomes we call this as a sample space. Now second one, event. Event is nothing but a subset of sample space. Sample space. For example, let us assume event E as when you roll a dice, all even numbers. All even outcomes we call this as event E1. Then event E1 will be 2 comma 4 comma 6 by rolling a dice. Now let us go into some basic definition of probability. The probability means probability that event E occurs will be total number of elements E by total number of elements in sample space. That is, for example, let us take an example. Now we will take the same event definition. Let us say you roll a dice. Then the event E is the even outcomes 2 comma 4 comma 6. Therefore number of elements in E will be 3. What is the sample space? Omega equals to set of 1 comma 2 comma 3 comma 4 comma 5 comma 6. That implies probability that event E occurs, or probability that even number is rolled is total number of elements in E by total number of elements in omega, that is 3 by 6, 1 by 2. We denote this by P of E, number of elements in E by number of elements in sample space. Now let us do some basic properties of probability. The first one, probability of any event will be always less than or equals to 1. Since total number of elements in E is less than or equals to total number of elements in omega. Because E is subset of omega, so total number of elements in E is always less than omega, total number of elements in omega. Now the second, if we take two events E1 comma E2 such that E1 is intersection E2 is a null set, that is no two elements in are common, probability that E1 plus E2 will be probability of E1 plus probability of E2. Similarly, if third one E1 is subset of E2, that is E1 union E2 is equals to E1, then probability that event E1 plus E2 will be probability of E1, that is total number of elements in E1 by total number of elements in omega. These are some basic properties. Now let us do some examples. If two dice are thrown simultaneously, represent sample space of the following events. The sum of numbers coming up to greater than A9 and the sum of numbers coming up is 8. So they are saying that we want to find events where the first one is sum of numbers coming up greater than 9. Now let us do the first one. Two dice are rolled simultaneously. So the omega will be 1 comma 1, 1 comma 2, and so on. 1 comma 6, 2 comma 1, 2 comma 2, so on up to 2 comma 6. Like that up to 6 comma 1, 6 comma 2, and so on 6 comma 6. This will be a sample space and cardinality of sample space will be 36. So now for event E1 we want that E1 equals to all sum of elements greater than or equals to 9. That means sum of elements will be 9 or 10 or 11 or 12. Therefore event E1 will be first sum of elements with 9, 3 comma 6, 4 comma 5, 5 comma 4, and 6 comma 3. These will be the sum such that it is 9, and for sum of elements should be 10 will be 5 comma 5, 6 comma 4, and 4 comma 6. And now similarly for 11 it is only 5 comma 6 and 6 comma 5, and for 12 it will be only 6 comma 6. So the event E1 will be this, and cardinality of E1 will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now for E2, E2 is saying that sum should be equals to 8. That means E2 will be 4 comma 4, 3 comma 5, 2 comma 6, 5 comma 3, and 6 comma 2. So event E2 will be this, and number of elements in E2 will be 1, 2, 3, 4, 5. Let us go into next problem. If a leap year is selected at random, what is the chance that it will contain 53 Tuesdays? Now, a leap year contains 366 days. That is 52 weeks and 2 days. So, the event is the extra 2 days, any one of the 2 days should be Tuesday. So, event equals to either Monday and Tuesday or Tuesday and Wednesday. And random sample space will be Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday, and Sunday, Monday. So, cardinality of event equals to 2 and cardinality of omega equals to 1, 2, 3, 4, 5, 6, 7. 7. Therefore, probability of event E occurs is equals to 2 by 7. Now let us go into next topic. Representation of probability using Venn diagram. Of probability using Venn diagram. Now for this, we generally assume a sample space as universal set and the event E we are taking as A. Then probability of A will be this one. If we take this as A, this as omega, then probability of A will be that. And probability of A union A intersection B is A, B, and probability of A intersection B will be this, the shaded part. Similarly, for probability for A union B, means both A and B occurs. I will write here probability that any of A or B occurs will be the shaded part. Now, probability that any one of them occur. This will be A union B minus A intersection B. Now, independent events. We say A and B are independent if Probability of A intersection B is equals to probability of A into probability of B. That is, for example, let us take you have rolled a dice. Make sample space. Then let event A equals to even number occur and event B equals to the number is less than or equals to 4. Then probability of A intersection B is event occurs and less than or equals to 4. That means either it is 2 or 4 by 6. That is 2 by 6, 1 by 3. Now, what is P of A? P of A equals to number of A elements in A by total number of set. That is 3 by 6, 1 by 2. And P of B. P of B equals to total number of elements in B by total number of elements in sample space. That is 4 by 6, that is 2 by 3. Therefore, P of A into P of B equals to 1 by 2 into 2 by 3, that is 1 by 3. Therefore, events A and B are independent of each other. Since P of A intersection B equals to P of A into P of B. Now, why they are called independent events? Because the probability of one is not dependent on other. That is, probability of A does not depend on probability of B. Probability of B can be anything and A can be anything, but these two are does not depend on each other. For example, let us say you say event A as the first. When you are tossing two coins, the first coin is tails. Let it be event A, and event B be the probability of second coin is head. Event B is the second coin is heads. Toss. And the event A is the first coin. Coin toss is tails. Now, whether the first coin is tails or head, does not depend on, it does not change the value, change the second coin will be head or tail. So these two are independent. Therefore, probability of A intersection B is, we know that it is 1 by 4, and probability of A is 1 by 2 and probability of B is 1 by 2. Hence, probability of A intersection B is probability of A into probability of B. Hence, these two are independent. This can be done for more than two values. For example, if we say three events A, comma B, comma C, and they are mutually independent. Mutually independent means no two are dependent on each other. Means A and B are independent of each other, B and C are independent of each other, and C and A are independent of each other. Then we can write that probability of A intersection B intersection C is probability of A into probability of B into probability of C. And it applies for n events also. Like probability of event E1 intersection event E2 intersection and so on intersection event En equals to probability of event E1 into hence on into probability of event En when E1 comma E2 comma hence on En are mutually independent. So with this we can prove one conditional probability. First we will learn about conditional probability and we will see how independency works in conditional probability. Now first is what is conditional probability? Probability that A given B is, that is, let us say there are two events A and B, then they are asking the probability of event A occurs when already event B occurred. That is, event B already occurred, then they are asking the probability of event A. It is denoted by probability of A given B, and it will be probability of A intersection B by probability of B. Now how we got this? It is, we can understand it by Venn diagram. Now let us see. It is sample space. It is A and it is B. Then we are asking probability of A given B. Means B is already done. So the new sample space will be only the B value. And the probability of A when B occurred means the part is only this. And this can be represented by number of elements in A intersection B. And the total sample space will be only B since B is already occurred. That is number of B. That equals to A intersection B by omega plus into sample space by number of elements in B. That is probability of A intersection B by into 1 by probability of B. That implies probability of A given B. Probability of A given B equals to probability of A intersection B by probability of B. Now, if A and B are independent, then probability of A given B is equals to probability of A intersection B by probability of B. And as A and B are independent, we can write that probability of A intersection B as A intersection B equals to probability of A into probability of B. Therefore, probability of A given B equals to probability of A into probability of B by probability of B. That is probability of A. See, as A and B are independent, the probability doesn't depend on B. This is the clear explanation. Probability of A given B equals to probability of A. When A and B are independent. Now, from this we can write one thing. We know that probability of A given B is equals to probability of A intersection B by probability of B. That means probability of A intersection B is equals to probability of B into probability of A given B. Also, probability of A into probability of B given A. And we call this equation as multiplication theorem. And the proof we have already done, like using Venn diagram, we have already done the proof for multiplication theorem. Now, if we extend this, we can write probability of A1 intersection A2 intersection A3 is equals to probability of A1 intersection A2 into probability of or we can write this probability of A1 into probability of A1 A2 intersection A3 given A1. This can be written as probability of A1 into probability of A2 in given A1 into probability of A3 given A1 intersection A2. For N1, probability of A1 intersection A2 intersection hence on up to intersection AN, we can write this as probability of A1 into probability of A2 given A1 into probability of A3 given A1 intersection A2 into hence on up to probability of AN minus 1 given, probability of AN given A1 intersection hence on intersection AN minus 1. It is for N events. Now let us do some problems based on this. Examples. The first one. If A and B are two events such that P of A equals to 0.5, P of A equals to 0.5, that is 1 by 2, and P of B is equals to 0.6, that is 3 by 5, and P of A union B equals to 0.8, we can write it as 4 by 5. Then find P of A given B. They are asking P of A given B and P of B given A. Now, first, we have to find intersection. How can we find intersection? From Venn diagrams, we can say that P of A in union B is equals to P of A plus P of B minus P of A intersection B. That means P of A union B 4 by 5 is equals to 1 by 2 plus 3 by 5 minus P of A intersection B. That means P of A intersection B equals to plus 3 by 5 minus 4 by 5. That is 1 by 2 minus 1 by 5. 5 minus 2 by 10. 3 by 10. We can interpret as 3 by 5 into 1 by 2. That means we got that P of A intersection B is equals to P of A into P of B. This is P of B and this is P of A. So we can write P of A intersection B equals to P of A into P of B. Therefore, A and B are independent. If A and B are independent, then P of A given B equals to P of A, that is 1 by 2, and P of B given A is equals to P of B, that is 3 by 5. So P of A by B is 1 by 2 and P of A given B given A is 3 by 5. So the answers are 1 by 2 and 3 by 5. 1 by 2 comes 3 by 5. Now let's solve the next another question. A bag contains 5 white balls and 8 red balls. Two draws of 3 balls each are made without replacement. What is the probability that first draw gives 3 white balls and the second draw gives 3 red balls? Now they have given that 5 and 8 red balls, 5 white and 8 red balls were there. Let's assume all of them are different. Then in the first draw we want 3 balls only white, and in the second draw we want 3 balls only red. That means let us take this as event A and take this as event B. Probability of A is total there are total number of choices, it will be 13C3 and only 3 white means 5C3. That is 5 into 2, 4 by 2 by 13 into 12 into 11 by 3 into 2 into 1. It comes 2 times. That is 5 by 13 into 11. Or we can write it as 5 by 143. P of B is equals to the second one has 3 red. Means we have already chosen 3 white balls. So we can remove those 3. Then there are 2 white and 8 red. So 8C3 by 11C 10C 10C3. That is, we can write it as 8 into 7 by 10 into 9 into 8 by 6. 3 times, or we can cancel out these two. 5. That is 7 by 25. 15. 7 by 15. So the P of B will be 7 by 15 and P of A is equals to asking P of A intersection B. Forgot to mention, this is not P of B, but this is P of B given A. Since we are choosing that the event A is already occurred. So we got 2 white and 8 red. So P of A B given A is 7 by 15. That means P of B given A is 7 by 15 and P of A is 5 by 143. They are asking P of A intersection B. Now we can write this as P of B into P of B given A, sorry, P of A in We can write this as P of B given A into P of A as P of A intersection B. Therefore, P of A intersection B equals to P of B given A is 7 by 15 and P of A is 5 by 143. This is goes by 1 3. So 7 by 143 into 3. Therefore, P of A intersection B is equals to 7 by 143 into 3. This completes our today's class, and in the next class we will be solving some high level problems in the probability which can be done easily if you know how to do. And we will see you in the next class. Until then, bye bye.